Hi, class. Welcome to week six. In a brief way, I want just to go to week six and explain you what are you gonna get, what are you gonna learn this week, and also the project that you need to complete this week, the project one. Okay. As you can see, and I am quite sure that you already went over this, but I want to just explain a few things that I want you to pay full attention when you are working this. The objectives are there, so I'm not gonna go and take too much time over the objectives because you already know this. But the great thing about this week is that you're gonna be now working with the runtime to analyze the different data structure and how long does it take to do the operation, right? And which one it's more feasible, which one can I use depending on what I'm going to work on. That's why it is important first to know what is that I need to do, what are these requirements, and see which data structure actually work with what I am working on, what the project or the application that I need to develop. That way you know then um, how you want to structure it. Okay. The other thing is analyze the memory requirement of an algorithm. So also we're going to analyze the memory requirement of an algorithm. As you know, when you write a data structure, all of that information go to the memory allocation. So how can we, allocate the right information into the data, which data structure and how the memory is going to be working. What is going to give me the faster speed when I'm running my data structure. Some of them are going to take longer, some of them are going to be faster depending on what you need to do, what needs to be done. You're going to pick the right data structure. So analyze the amount of memory that it is needed to store the data for given algorithm. That is key. As we know, when you write a code, that is going to be stored in your memory. So depending on the different functions and how the data structure is put together, that can take a lot of memory space and it slow down your program. So therefore, it is important to know which data structure it is most feasible. I will use the word feasible, or it's gonna work based on the requirement that you have. Okay. Analyze the input and output in the data structure needed in programming applications. So right now I'm working a lot in Python because I'm getting ready for machine learning. That's something that I am working on specifically for my future education, which is going for my doctorate degree, my PhD in data science. And this is something that I have to deal with all the time. So making sure that the program I'm using is the program that it is that I need or my application needs, to meet those requirements. Okay, so um, you can you can go over this the module overview. I don't want to go into all the details on how to do the BO, et cetera, how to run the program and do the calculation, all of that in there. Please go over the module, review it, and also make sure that you review the extra information that we provide. But one thing that I want you to pay attention first, your ZBooks. Do your ZBooks. Those are the practical exercise that you're going to have. So to kind of understand more the assignment and also understand the week material. And submit your project one. When it comes to your project one, I want to show you this and I'm going to close with this too. In your project one, you're going to have this document. You're going to have the pseudocode document. Some of you are asking me, hey, um, what do I need to do here? If you go over if you go over what we just went here, if you go over the class or over the module and you look into project one guidance and the rubrics, so this is everything that you have to do. It is in there. Okay. Now it is important for you to understand that I need to see the pseudocode for these three data structure that we already covered: vector, hash table, and the BST, the vanity search tree. Okay, you need to do that. That needs to be here. And as you see, the assignment actually tells you you have the hash. Okay, you have the hash right there, you got the vector, and you have the tree. So I need to see that. The other thing I want you to pay attention carefully is the runtime analysis. You need to have the runtime analysis for each of the data structure, not for only one. You need to do the calculation because this is when I'm going to know if the one that you pick makes sense based on your analysis. Because you might say, "Oh, I want to for my project, I will pick a vector." But then when I go to your analysis and see your recommendation, you're gonna say, I'm gonna look and say, "Well, why do you pick that if in the runtime it takes longer than doing a tree?" So please pay full attention to this. Make sure you do that. But make sure that you're covering the rubrics. Because if you go to the rubrics, look at what it says here. The runtime analysis, I need you to pay attention to the advantages and disadvantages. You need to make sure that you write that for every data structure. A vector, are the pros and cons? Okay. And then when you do, for instance, the binary search tree, pros and cons, hash table, pros and cons. And then you're going to give me, based on your analysis and what you did, give me your recommendation. Why are you recommending that? Versus the other one. Okay? So make sure you do that clearly. Use your subtitle, bold the title. So make sure that you can use it like this. You can use it like this. Just put run table, runtime evaluation, put every data structure, write the pros and cons. Nice, very organized, clear. I don't want to see one page, 2 page, 3 pages. This project, it have to be more than 5 pages. 1 or 2 pages, you won't be able to write all of this. Even to write the pseudocode, it would take you more than 2 pages. So please, give 110% of yourself. You've been doing great. I just want to make sure that you get it done, and I just want to make sure that I um, emphasize this part of the project and that you know why you have to do. All right, so I don't want to take more time because this is a lot of work that you need to do for this week. So please make sure that you get it done. And if you have any question, reach out. Send me an email, and I will respond to you. You know, within the 24 hour that I have, or probably before that. Okay. So have a good one, and let me know if you have any questions.